Hey guys, in the data structure world, linked list is one of a basic linear data structure. So this video regarding linked list. In this video, we will discuss properties of linked list and type of linked list. Under type of linked list, we are going to discuss single linked list, double linked list, and circular linked list. Every linked list is a collection of nodes. We can represent a node like this. This node is containing data in here, and it contains the next node address in here. We can represent a simple linked list node like this. This is a collection of previous nodes, each node linked with the next node. So we can call linked list for this. First node contains 12, second node contains 10, and last node contains 25. We have to point last node next address to null. So this is the last node of this linked list. Every linked list last node is pointed to null. First node of the linked list is called head of the linked list. But keep in mind, head is not a separate node. It only contains reference of the first node. We can represent a simple linked list like this. What about the head is pointed to null? That means linked list is empty. As we all know, arrays have fixed size. Unlike arrays, linked lists don't have fixed size. So linked list is a dynamic linear data structure. If we need an unknown number of objects for our application, we can use linked list because of this behavior. Now let's see what is the conclusion so far. Each node have two parts. One is value and the other one is the address of the next node. Second one is the first node of the linked list is the head of the linked list, and the last node next address is pointed to null. Fourth one is, unlike arrays, linked lists do not have fixed size. So we can call a linked list is a dynamic linear data structure. That's all about properties. Now let's move into linked list types. There are three main types of linked list: single linked list, doubly linked list, circular linked list. First, let's see what is the single linked list means. Actually, previously discussed, everything is related to single linked list. So I won't discuss everything here again. Now we know this is how a node of a single linked list looks like. As we all know, this is a single linked list. We can traverse from head to null through this linked list because each node is linked with only the next node. We cannot traverse to the previous node. So because of traversing one direction, we can call this linked list an unidirectional linked list. Now let's move into doubly linked lists. Node of a doubly linked list is same as a node of a single linked list. It contains data here and it has the address of the next node here. Now you can see this is a single linked list node. Now we have to add another part to turn this into doubly linked list node. This new part has the address of the previous node. Now this is a complete node of a doubly linked list. So a singly linked list node only has the address of the next node. But a doubly linked list has the address of the next node and the address of the previous node. That is the difference between these two nodes. Now let's see how is a doubly linked list looks like. This is a node of a doubly linked list. Let's use this node to draw a doubly linked list. First node contains 15, second node contains 17, and the third node contains 10. First node previous address is pointed to null because there are no previous node than that. Same as previous address, next address also pointed to null. This is the head of this linked list. Same like single linked list, in here also we can traverse between nodes. Because of having next address, we can go forward. And the new thing is, because of having previous address, we can traverse backward as well. Now you can see here, using doubly linked list, we can traverse backward and forward. This kind of linked list we call bidirectional linked lists. Now let's see what are the differences between singly linked lists and doubly linked lists. A singly linked list node only takes space to store the data and the address of the next node. But a doubly linked list node needs extra space to store the address of the previous node. Singly linked list is unidirectional, but doubly linked list is bidirectional. We can easily apply operations to the singly linked list. But when we add operations to the doubly linked list, it will increase the number of modifications. We will discuss about these operations later. Now let's move into circular linked lists. We can generate circular linked list using singly linked list and doubly linked list. Let's see how we can generate a circular linked list using a singly linked list. We can draw a linked list like this. And what we need to do is point the last node pointer to the first node. Now this is a circular linked list by singly linked list. Let's see how we can generate a circular linked list using doubly linked list. To turn this into circular linked list, we have to point the last node next address to the first node and first node previous address to the last node. Now this is a circular linked list by doubly linked list. Because of this circular behavior, we can traverse to the previous nodes in singly linked lists. If we use a circular linked list, we have to be careful because sometimes we have to face an infinite loop. Another thing is applying operations like reverse addition are a bit more complex than singly linked list and doubly linked list. That's all about circular linked lists. In the next video, let's see how we can apply operations to a linked list.